Hello and welcome back to learn more about these GM/Ford 10-speed transmissions. And in this video, I'm going to focus primarily on the valve body. We're going to look at the oil pump, and we're going to look at the auxiliary oil pump, which is used during a stop-start or idle stop mode. They let that thing operate to keep kind of a little bit of pressure in the transmission. But we're going to focus on the valve body and the overhaul. Now there will be a separate video on like how the hydraulics actually work. This is more for functionality and for testing to see if everything is good, like if you're doing an overhaul. So we're going to start by looking at this Ford, since we went through a Ford when we went and overhauled it. We're going to look at the early Ford, and then we'll show some differences that might exist on the late model Fords. And then we're going to jump over to General Motors. We're going to look at the two variations of the General Motors, and they'll both be the second generation. So let's jump right into it, and we're going to, like I said, look at this Ford valve body first. Now starting off with this early Ford valve body, I went ahead and, as you can see, I already pulled a lot of the pieces and parts out. I went ahead and labeled these solenoids. These solenoids just fit right into these passageways right here on the end. They're supported into the valve body by these clips. You're going to see at some point there's actually a stiffener for these, because this is actually an issue with some of these valve bodies, is that these clips do not support the solenoids very well. And those solenoids directly act on these valves. These valves will actually move back and forth, and it's not a lot. Matter of fact, if you take a look at the pintle tip, that's the part that comes out right there. And that's about as far as it comes out, and then hydraulic pressure will push it flush, and electromagnetism will pop them out. So that's the total movement of these valves from that position to flush. That's all these do. They're called linear solenoids because they don't control pressure. They physically, that little finger there just kind of pushes on the valve. And this valve is going to sit there and just move that little bit amount, whatever that comes out. And it's going to direct either block off pressure to a clutch, or it's going to allow pressure past. Now, actually on this earlier unit, the pressure that leaves this valve is actually going to go over to this other valve body and these other valves. And they call them latch valves or sometimes gain valves right here. And this is the valve that's actually going to control the pressure to the clutch assembly. And you can see they got different spring tensions. There's a larger surface area right here. These are right here on the end, about 346 thousandths. And next to the spring, about 388 thousandths. All four of these are pretty much the same size. These four latch/gain valves, whatever you want to call them, these are responsible for clutch pressures. And this one right here is a lube. It looks the same, but it's a little different. These are all the same size, all these lands. This one here, that lands, these two are smaller, that one's a little larger. So that way when hydraulic pressure gets into this spot here, it can move it over and compress that spring. That's the idea. When it moves it over, it's going to let pressure, line pressure, go to a clutch. So these are all different responsible valves for the clutches. They're joined with these four right here. Matter of fact, if you look, these four valves have 4 spools on them. These two have 5. Well, these 4 valves work with these latch/gain valves. Other than these one that have 5 spools on them, they directly operate the clutches. And those specifics, those are focused primarily on the first generation General Motors and on this Ford valve body. On the second generation General Motors, they actually got rid of these little latch/gain valves, and they're doing everything through the valve. So the late model or the second generation 10 speeds from General Motors don't use these at all. Ford still uses those, at least as of right now. So that was all that was living in this section right here. All these different solenoids, all 6 of them, and their valves and their latch valves, they're kind of responsible for the actual clutch pressures themselves. And then on this side of the valve body, we got a couple more valves. Living in this passageway is a line pressure solenoid. And that's going to live in front of this anti-backflow valve. It's got a spring on each side, and that basically just kind of lives in that little spot of the valve body right there. And then next to it, we've got the torque converter clutch priority valve. And we've got a valve and a spring that's associated with it. And you can see marked all over my valve body, I've got all these blue markings. These are all different places where we can do vacuum tests to see if these valves are sealed off properly in their bores, and they'll find out they either have excessive leakage or if they're any good. When we do the vacuum test, if this bore is egg-shaped or it's worn out, kind of in an odd fashion, when we place vacuum into this passage with the valve in place, it's going to leak into its adjacent bores, and it will fail that vacuum test. So what we're hoping for is that when we do these individual tests, that we have a decently high vacuum. And there's different values that you would expect. And the Ensonics provides information for pretty much where to test. You can go to sonics.com and get a vacuum test guide, and they have all the part numbers for the different pieces and parts that they, if they make them at least, they'll tell you where to check it. And if they make a valve that is a replacement for that, they'll have that valve listed up here. So when you go to the specific valves, you'll find that if you click on the instructions, they usually have a section where they'll show you kind of the sample test results, like where you're checking it, just like on the vacuum test guide, and maybe what you would expect to see as far as a result. Now, this is a soft value. It doesn't mean you have to hit 14 or 18 in this example. If you're a little lower than that, well, it all depends. Depends on what the symptom was. If it's related to that symptom, then okay, yeah, you'd want to go through and address that because it's obviously a little lower than what you would expect. But if it's completely unrelated, then you're like, oh, maybe that's still fine. Also depends on where you live. Maybe you live high altitude up in Denver or something like that. You can't expect to get the same results as somebody here at sea level. So that's where some of these techs, they'll go through and they'll kind of create a notebook, or they'll memorize, or just kind of get an idea of what's considered good or bad after testing many valve bodies. The beauty of this, the good and bad, is this valve body is brand new. So whatever we find on this, whatever the result is, we know that's what a brand new valve body would have. So that will give you some kind of reference to think of like what you're checking versus what new is. And you might be able to make a better decision based on that. That's all I got to say about that. So before I go through and put the valves back in the valve body so we can vacuum check these things, I want to go through what's going to be in our upper valve body. The lower valve body was predominantly the solenoids and the valves that are responsible for that, but our upper valve body has a little assortment of valves as well. I got this thing kind of laid out a little weird. These are oriented like they're in this fashion right here. So this top valve right here is the clutch gain control valve, and this is the torque converter clutch regulator valve. This long one right there. And then this is our main regulator valve. So kind of used to seeing the long valve being a regulator valve. In this case, this is our regulator valve right here. And now coming over to this side, we've got these four valves, which are identical. The springs are different, but the valves are the same. And they work into these bores right here. And they coincide, they are the latch valves. This one is for clutch A on this early unit. Now these things change around a little bit, so you want to be aware of what you're working on. But this one's responsible for clutch A, this one's responsible for clutch F, clutch B, and then clutch C. And those four valves are going to work with the four solenoids and valves that have the four lands on the valves right behind the solenoids. And this guy right there, I'm missing the little thermostatic element that goes in there. I'll show you that in a little bit. This is the cooler bypass valve. So when the transmission heats up, the transmission fluid heats up, there's a little thermostatic, kind of a wax-filled valve there that when it expands, it pushes out, so it's temperature activated, pushes this valve over, and it opens up a circuit that forces the fluid through the cooler. But when the transmission fluid is cool, it'll bypass the cooler so it won't get overcooled. So it allows for the transmission fluid to heat up quicker. And like I said, I'm missing the little thermostatic element. I'll show you how that thing works though, because I've got some on the GM units. I don't know what I did with that. It's probably rolled off somewhere on me. But this valve right here looks like those others, the latch valves or gain valves. But this is actually for lube control. And a lot of times students ask about these little shiny spots like you see there in the middle, right there. Right there. That is probably part of the manufacturing process. That is not damage that's done to this valve body. There's a little blue paint or something on there. But yeah, that little speck right there, you'll see that on a lot of valves. It's probably in the manufacturing process. There's probably a little robot or something that grabs onto that when they're anodizing it. So that is not a wear area. Whenever you're inspecting valves, what you're going to be looking at is the surface, like right through here, that contacts the valve bore. And you'll notice, I know with this dark anodized valve, it's kind of hard to see it, but they put these little ridges in there now. And you've probably noticed if you rebuild transmissions a lot, Superior transmission, they do that on their valves that they engineer and design. And it's there to kind of keep a little lubricant in there and kind of provide a place for debris, or debris, I guess that's probably what you're supposed to say it. I see those little grooves now a lot on OE valves. Okay, so as you can imagine, when you're disassembling this transmission, you are going to want to pay close attention to where these springs go, because these springs are calibrated for whatever clutch set they're operating. Some of these springs are higher tension than others, so it'd be a good idea to take a picture as you pull them apart. Try not to get them mixed up, or else you're going to have all kinds of issues, and it won't shift right, because this is going to ultimately determine how much pressure is going to go to those clutches. And so when those solenoids are operating at a certain frequency and duty cycle, that's going to end up working on this valve, and then the spring is going to ultimately determine at that given duty cycle what that given clutch pressure will be. So if you get these mixed up, your clutches are going to have the wrong pressures. So that would be a horrible thing. So don't do that. Okay, so I'm going to go through and I'm going to put this valve bodies back together so that way we can go through and vacuum test it. So now going through that lower valve body, I'm going to go ahead and put these valves and these solenoids back in. And hopefully you pay good attention when you pulled these solenoids out. You maybe marked them or laid them out in an order, because they actually have on their part numbers and their codes here, they have what they call a band number. And that band number is going to be an indication of how this solenoid acts. So what they do from the factory is they assign this thing a little code. And see where that says right there, number 3? Well, that's how this solenoid acts. And that 3 is going to mean something to its calibration and how it works. So you want to make sure the 3 solenoids go into the spot that's identified for 3. Solenoids might all fit in the same spots, in the same holes. That one has a 3 on it as well. Whereas that one, the band marking on it is 2. So you wouldn't want to get this 2 swapped into a spot that's supposed to have a 3. In theory, you could end up with some kind of a shifting related issue. So I'm going to go through and make sure I put the solenoids back in the same spot where I removed them. Now when you put these things in there, you're like, man, that is sloppy loose. There's not a precision fit there whatsoever. And when you put these clips in, they do a good job of stiffening them up. So it's pretty stiff now. But they found that over time that these things still end up moving around too much. So what the aftermarket's done is they've created these stiffeners to go in place of these. So that way it kind of wedges these things in there much more solidly. I would definitely recommend getting those. But we're going to go through and assemble this back the way it came apart so that way we can vacuum test it. One thing you might have noticed that these valves don't have any springs. They just live in the bore with the solenoid on one end. What they're doing is that they're using what they call exhaust backfill pressure and kind of filling that up on the side. That's a low pressure that keeps this valve shuttled over towards the solenoid, and then the solenoid works against that pressure when it's operating. Now I have to put the anti-backflow valve and the TCC priority valve in their place with the solenoids, and I'll be ready to vacuum test. So real quick, when you're doing a vacuum test, you're going to use this little vacuum plate, and hopefully you've got one of these rubber gaskets. I marked off all these passages. Depending on the vintage transmission or valve body you have, it might be different. We've got all these different valves. This is the clutch gain control. That's the torque converter clutch regulator valve, the line pressure valve. This is the cooler bypass, the lube circuit, and then these four are latch valves, or they're like individual clutch gain valves. And really going through down the test, sometimes you have to put your finger over a passageway, but before you start, you want to make sure that you're calibrated. So you put your finger over the end of it, and you should be pulling 25 inches of vacuum. Go into the calibrating orifice, you should be pulling 5 inches. If not, you adjust your dials until you get that. What this does is it allows every vacuum pump to have similar results, no matter how strong or weak it is. So starting off with the lube control valve, 23 inches, going over to the torque converter clutch. Now this torque converter clutch one is weird. If you just check it directly, you'll see you don't get anything. But if you go through and push on the end of the valve, get it in there, hopefully you can read that gauge, but I'm getting 19 inches. So going down the line, just be aware of what you're testing and what you're expecting. So I already tested this valve body, so I know everything passed. Everything's good. Every once in a while when you check something, you'll get no reading. We'll make sure there's not an opening or a passageway on the other side that you need to block off with your finger. Usually in the instructions, they let you know about that. But if they don't, well, there we go. I found it. You can see I'm getting 23 inches on that one. So we've got the lower valve body that has all of our different solenoids. You can see we want to check the solenoid retainer end and also the exhaust backfill ends of these solenoids. And then on this side, we check the priority valve. There's a couple spots along that we check. Now when you check the solenoids, check these first and make sure your valves are kind of all pushed towards the solenoids. Otherwise it's going to leak massively and it won't work. And if you check this side first, it's going to suck the valve over, and then you'll have to push them all over again if you want to check the other side. So if you go through and make sure every one of these things are pushed back towards the solenoid, it looks good. Then I can go through and check one at a time. 20 inches, 19, 19. So those check out real nice. And over here I've got my torque converter clutch priority valve. And I have to put my finger over a slot on the back. I'm getting about 16 inches. And then where my throwing star is at, and about 20 inches. So this valve body checked out really well. There was no problems with it. The vacuum readings were great, but that's to be expected because this thing doesn't have any miles on it. So to finish off assembling this lower valve body, we need to put these little pulse dampeners in there. I already went ahead and put them in. You can see this one here, and I actually circled that because this one you can vacuum test. Matter of fact, I think the suggested value is 18 inches. Now that little dude right there, that's the torque converter clutch dampener. And then I've got another dampener here. You can see that's the pistons facing up. Pistons facing up on this one. These just have that little spring on the bottom of it. But on this one right here, it's kind of used in conjunction with the auxiliary oil pump. This actually faces down, so the spring faces up. So to continue assembling this, we'd put the spacer plate on. Now there are no check balls in this valve body. The later generations and the later years, they actually start using the check balls, but this early unit does not have any check balls, which is nice. And when I place my spacer plate on there, I've got this little spot right up here where there's like a spot for a little plastic push kind of locator deal. It's like that. If you didn't have that, probably wouldn't be the end of the world because it's also held down by two Torx bolts. And that kind of keeps things centered up. If you did have check balls, this would be handy because when you're flipping this thing around, they wouldn't fall out onto the bench. Before tightening these Torx bolts, I'd probably pay close attention to see if if there's a little bit of wiggle room in there, and make sure things are centered up as possible. You can see that there is still a bit of slop even with the little plastic push deal and these two Torx in their place. So take a look at the spots where the bolts go through and make sure there's nice clean pass through so you won't be fighting that. These bolts get torqued to 76 inch-pounds. Not too tight. Don't really do anything though, just hold that plate on. Okay, so let's take a look at this oil pump that they've got. On this Ford unit, one of the things that's unique about it is it's got these spur cut gears, straight cut gears. And obviously it matches the gear set that's in the front support. So this is kind of notorious for making a whining sound. But the alternative is what General Motors does. And they've got helical cut gears, or the gears are cut on an angle. So they're quieter, but these put a little bit of a side load when they're meshing because of the angular cut. So that side load ends up putting a little bit of side load on that idler bearing in that front support, and that wears out that idler bearing, and then that becomes loose and it destroys the pump and sheds metal. So a lot of people with the General Motors transmissions are figuring out ways to swap over to the straight cut gears by using the Ford stuff to eliminate that as a potential problem. The only disadvantage is that you might be introducing a little bit of noise. So we got these three pumps here. I just really wanted to show you the design, with the straight cut gears that's on the Ford. Now on this one here, we've got 3 mounting bolts. This is a Ford pump as well, but you can see it actually has 4 mounting bolts. Straight cut gears still though. And then on the GM, they got the 3 mounting bolts, but they've got the helical gears. The Ford system seems to be a little bit more robust. And as far as the pump is concerned, there's really no difference in the way the pump operates, it's just the way that gear drives it. And to take it apart, first we got to take this little plastic cover off the outside. It just kind of clicks into place. Then I need to pop this E-clip out. Make sure that doesn't shoot across the room. And with that E-clip off, I should be able to gingerly get that gear out. I don't want to break my plastic cover, but this gear should come out pretty easy. So that's the pump drive gear. Now I've got some T30 Torx to remove. So you'd want to take apart this oil pump so that you can inspect it. It's a vane type pump. It's a variable output pump. So the pressure regulator valve and the valve body will control the pump slide on the outside to change the pump's output. There is a dowel pin and a roll pin that kind of keeps these things in position. There's the dowel there, and actually that's part of like the pump slide. And then I think it's either here or here, probably here is the roll pin. That keeps this thing from just kind of blasting apart because we do have this spring in there. That's like the pressure relief valve or check ball that's in there. So you might need to tap on it a little bit to get it to kind of start pulling apart. Well, probably could have done that better. This is that spring for the pressure relief, little check ball that it pushes on. That pushes that check ball into that seat right inside there. I know you probably can't see that too well, but the check ball lives inside there. There's a ring on the top and on the bottom of the rotor. So this ring right here and that ring keep these vanes kind of pushed out to the pump slide. This right here is the pump prime spring, and that keeps the pump shifted into the maximum displacement position. So looking at the pump shaft, if it were driving this, you could see it's kind of offset to the side, so when it's rotating, it's going to create a suction and it's going to turn around and squeeze it out. To limit the output, the pressure regulator valve will deliver pressure into this area right here. That will actually pivot this pump slide over. See if I can do it without shooting this thing apart, killing me. So that'll pivot that pump slide over, and you can see it equalizes. Whoa, it's coming apart. it equalizes the space around the pump slide, and that reduces the pump output. I'm going to go ahead and pop this spring out. Put your hand over it so it doesn't shoot across the room and kill somebody. So when you have the pump apart, you want to kind of inspect it for any gouges, any scoring. Check these surfaces right here to make sure they're not torn up by the vanes. Like if material got in there, it would likely carry that around and do some damage. Same thing for the other side of the pump half right here. Make sure this is good. Now on the pump side itself, we have this Teflon sealing ring that seals on the outside. This little O-ring just kind of works as a spring and pushes that Teflon seal out. So that O-ring just kind of lives inside there. And that Teflon seal just kind of rests on the outside like that. So that way that O-ring kind of deforms and squeezes out on that Teflon seal. That serves the same purpose as this O-ring right here. So this O-ring pushes on this Teflon seal. And that seals that up against the cover to kind of prevent leakage from around the pump. So these O-rings are acting like springs, pushing out on the Teflon seals. And that all rides on the inside of here, so as long as this is smooth, there's what they call the fingernail test, where if you run your fingernail across it, you shouldn't be able to catch it. Sometimes you'll see scoring, but you might not feel it, so there's nothing wrong with that. Now when you go back together with this, it probably would make sense to make it easier. You leave these two pieces out, the O-ring and the Teflon seal. You put this back in place right here. So I'm going to drop my O-ring in there, and then I'm going to drop my Teflon seal in there. And I'll shift this around to make sure that Teflon seal is in the groove. So now we got that Teflon seal and that O-ring in the groove. You're like, okay, but what's going on here? I need to slide this all over the that dowel pin. It helps to do it this way because it's hard to squeeze these pieces in, but it's a little easier to slide this over the dowel pin. So what I'm doing is I'm squeezing this part right here with my thumb to kind of draw that Teflon seal in there, and that gives me enough room to get that dowel pin through there. All right, I might give it a tap or two. Make sure these parts are all seated. That looks good. It's seated nice and flush all the way around. My Teflon seal's in place. I got this Teflon seal in place. I didn't have to put that in ahead of time, but it's there. The next thing I'm going to do is I'm going to get my priming spring back in there. If you remember that priming spring, its job is to hold this slide into the maximum output position. And then when the pressure regulator has enough pressure, it can put pressure on this side and it'll compress that spring and shift this pump slide over like that. And that will reduce the output of the pump. So it's like max output, minimum output, max, minimum, or somewhere in between. It'll just output just what the transmission needs. So to get this in here, I could use a pair of channel locks and squeeze it, or I could use a vise and have this part sticking out of the vise a little bit and then squeeze it. I might try the vise. So with the vise, aim the spring toward your enemy. But you compress that, you have this sticking out a little bit, maybe a third of the way. Now you can push this spring into that pocket where the, oh gosh. Feel a little nervous right now. Yeah, a pair of channel locks might have been safer. But heck, if you're strong, you might be able to push it in with your thumb. But probably not. So the most common ways to misassemble this pump is, or the most common mistakes that people make when building this pump is two things. One is they don't check to make sure that the pump rotates while, at different portions to make sure this thing's still spinning as they're tightening parts up or as they're assembling it. And if you get yourself in a bind and you start tightening things up, you're going to start damaging parts. So it's always a good idea to continue to rotate these parts while you're tightening the stuff up. Another area is they get, it's Teflon seal right here, it might fall out of position. Might, like, as banging around, it might fall off to the side. It might be under the cover at that point when you're trying to get these parts together and you don't realize it, so that puts the pump in a bind. So I usually put a dab of trans gel in there, kind of like that's what I did. That's the reason why it's so gooey right now. And that trans gel is what's gonna hopefully keep this thing from accidentally popping out. So, like I said, make sure this thing has the ability to spin while you're assembling it, and if it ever gets locked up, then there's an issue. Now, another thing to kind of pay attention to is this thrust washer right here that sits on this pump shaft. If you look, it sits about, this is sitting in there, sits about like, I don't know, 1/8 of an inch above this surface right here. Well, that's the thickness of this little kind of intermediate plate that goes in there. If when you're assembling that, the whole assembly and this thrust washer sitting above that plate, this isn't in all the way and there's something keeping it from dropping. So when looking at this pump rotor, you can determine that, well, it probably doesn't matter which way you assemble this thing because the depth of this pocket here is the same on both sides. But it is a good practice to return it the way you took it out. Like here I see a dimple on this side, so it has an identifying dimple right there. If I can get the light to glare off of it. It's right, oh, just saw it, right there. So pay attention to that when you take it apart. That will give you a way to remember how it went together. Now, this pump ring goes on the bottom. There's one on the top, one on the bottom, but we'll have to put one ahead of time before I put this pump rotor in. Now I can slide these vanes in. When you're dealing with pump vanes, unless they're brand new, if they're brand new, you can put them in any old way. But if they're used, take a look. You'll have one shiny surface all the way across. And then on the other side, you'll have like a shiny spot on the inside and the outside. So those rings might wear a little bit of a spot in those pump vanes. So make sure those go in the same direction. They're always going towards the rings. Otherwise, you might introduce a noise, and that's not good. So yeah, and if you're reusing these pump vanes, definitely inspect them to make sure they're going on the right way. And when you get it all together, you can put your top pump ring in. Now before I put this cover on, I'm going to want to drop my check ball into here and put the pressure relief spring in there. That's going to get squished down by this cover. This section goes over this roll pin and this section goes over this dowel. And that provides you usually with enough interference fit that you can just kind of squeeze this together. You might need to tap on it a little bit with the soft face hammer. So you're going to fight it a little bit because you've got the tension of this pressure relief spring, but you can get it over that dowel pin and that roll pin. Then get your top cover on. I have that shim in there, and that shim is sitting on top of the shaft, and I can spin the pump still. So you don't want to tighten any bolts up and draw these parts together, but you can get some bolts in there to kind of hold it straight and steady and try to guide you in a little bit easier. It's important to remember that these outer parts are just aluminum and it won't take much to crack one of those covers and ruin it. Also notice that when you go to tighten these things in by hand, that sometimes the very first turn is like tight, and if you back it off and try it a few times, it goes in a lot easier. It kind of basically makes it seem like it's really wanting to cross thread on you if you're not careful. So I'm going to use just 2 bolts to help guide it in, one on either side of the pump shaft, and kind of squeeze the pump together while bringing those bolts in. So this is pulling those 2 halves in pretty easily. I'm just using hand force here. I'm not taking my ratchet and tightening away. My pump does turn. And once you get all these in there and it seems like the pump halves are even and together, go ahead and give it a few of those, just a little snug. And still ensure that your pump can spin. If everything's good to go, finish tightening the rest of these. So Ford doesn't have a published torque spec for these bolts right here, but they do publish a torque spec for the cover bolts. These cover bolts are the same size as those, and they're 115 inch-pounds, so that would probably be a good torque to achieve. Go in like a star pattern, so that way you can kind of even out the stress on this pump assembly as you tighten it up. The cover bolts will only fit in one spot. They made it kind of idiot-proof in that respect. And now you can drop your gear back in there and put the E-clip on. Put your top cover back on. They'll just snap into place. And there you have it. You got your oil pump all done. When we mount the oil pump back into the transmission, it gets torqued to 71 inch-pounds. Next, we're going to look at our auxiliary oil pump. Now this thing is kind of neat. It has, when you look at the connector on it, it has 6 pins. They use the outer top 2 for 12 volts. One's powered up by the TCM, one's powered up from the battery. And then the bottom 2, one's a ground, or the bottom 2 outside ones, one's a ground, and the other one's a signal from the TCM on how it wants to operate. Now that signal is delivered from the TCM. It's 100 hertz, and it varies in pulse width depending on how fast they want the pump to operate. And we'll go through and actually bench test one of these things here in a little bit. But first I want to take it apart. Believe it or not, I mean, I'm sure this is completely serviced as a unit, but in the kit, in the precision kit, you get the start-stop pump components, in which you've got the O-rings and the filter, all that good stuff. So there are seals in here, and you want to inspect it. So you want to take a chance of just putting this in. If there's any contamination or anything like that, it's definitely worth taking apart and cleaning up. Pulling this end cover off right here will give you access to that filter. So it's just a simple little oil filter. You got an O-ring on the outer cover right there. So on this filter housing, you can see these 2 little standoffs right there. This is actually the inlet. There's actually a little pickup screen on the inside here. That's going to allow fluid to come into the pump. And then these little pump gears, when they rotate, they're going to create suction and then squeeze out. When they squeeze out, they're going to create pressure into this passage. And this passage goes to a feed tube that delivers it to the valve body. And this is the part that that pump rides up against right there. Kind of like that. So it's a simple little G-rotor type pump. This section right here has got a spring and a valve in there. It's a pressure relief valve. It's connected to the outlet. So if pressure gets too high, it can unseat and relieve that pressure. This thing's a little bit spring loaded because there's a kind of a preload spring that's on the inside of this thing. So it's going to kind of push itself apart as I take these bolts out. It won't shoot out on you though, or shoot apart. At least I hope it won't. So there's the motor and the motor windings. So you can't go through and directly measure these windings or anything like that. There's a computer inside this section, and I can't pull that part. I think it'll probably ruin it if I do that. And that computer controls the current flow through these windings so that they can change the motor speed and so forth. That's the reason why when you look, it's only got 2 powers, a ground, and a signal wire. So the computer, the TCM, isn't directly controlling these windings. It just sends a signal and lets a little mini computer in there, basically a drive inverter, drive these windings so that they can get this motor to spin. This is the permanent magnet motor. It's like a little shield they have around it, and they've got the permanent magnets built into this rotor assembly. So you can see this is a magnet. And based off of how they control the current flow through these windings, they'll be, because the electric current or current flowing through these windings will create an electromagnet, so they'll actually be able to kind of control the electromagnetism in the direction and speed that they want, and this rotor is going to follow that. And that's how they get this pump to work. So as far as inspection is concerned, I can go ahead and take a look at my pump gears, make sure there's no scoring or damage as far as that's concerned. Clean all this stuff out. I can replace these O-rings that are in there. There's this orange one right there. Then inside the pump drive, might not be easy to see, but there's a blue one right through there. And I could change my filter. Get the nice new filter in there. Has this cover built in comes in the kit. Change the little O-rings that are located in this filter for this filter. So basically, it's just a clean and inspect. Now I will show you here in a second a way that we can actually go through and test this and on a bench. So it'd probably be pretty nice to know if this thing actually works before going through putting this into a vehicle. So I'm going to go ahead and now put this back together. First thing I'm going to do is put the sleeve over this rotor like that. And then I'm going to lay in here this kind of cushion spring or preload spring. I don't really know what they call that. Then I'm going to slide these two assemblies over each other. Now, permanent magnet's going to want to suck the spring out, I'm sure. Give me a little bit of a fight with that, but that's all right. We'll get it together. And because of that, when I go to assemble this thing, it's not going to just drop into place because I've got to compress that spring as I go together. If you look, they give you just enough thread to get this thing started, even though you will be using the bolts to help compress this. Okay, so that went together all right. Put that pump gear in the housing. But you can see they put those little dimples there. So that way, now this inner gear doesn't really come off that shaft. I think I'd ruin it if I try to take it off. But that inner and outer gear both have dimples, so as long as they're facing the same direction, it's a good way to remember how this outer gear goes into place. Now I can go ahead and put it back on to the filter housing. There are no published torque specs for this. I would use something rather low, like 70 or 80 inch-pounds, because it did not have much torque when taking it apart. So that's one thing you could do when you're taking it apart is pay attention to how much torque it takes taking it apart and try to mimic that when you're going back together with it. If you're leery, you could always put a little bit of Loctite on there and just kind of be conservative with the torque. And lastly, with the new filter and the O-rings on the cover, and this filter has a cover that has a lip on it, like you can see where it raises up. It doesn't have it on this side. And the lip faces out. So now once I torque all of this, I'll have my auxiliary oil pump done and I can go through and bench test it. So to bench test this, I'm going to use my little booster pack here, or it's a little cart with jumper cables on it, 12 volts. And this little box that I've got here actually outputs a signal. It's like a frequency generator that I made. You can buy frequency generators. I know AES Wave sells frequency generators where you can select the frequency, the duty cycle, the voltage, or you can make one on your own. I can't remember if I have a video out on this or not. If I don't, I need to make one. So just show you guys how to make this. It's using just some simple chips. There's probably $20 worth of stuff in here, if that. But what I did is on the vehicle, I measured it uses 100 hertz. And when it was doing a test, when I used the scan tool to do a test, it outputted 50% duty cycle. So I mimicked that on this. And like I mentioned, these top two terminals receive 12 volts. There's 6 terminals, but they don't use the middle ones. Actually, they do on the bottom, but that's like a feedback circuit. But on the top 2 outer ones receive 12 volts. You could see this bottom one here, I guess as viewed from you guys, it would be on the right side. That's ground. And then what I have in a white cable, that's a signal. So you can see that's why my signal is going over to my box. So right now I have this box putting out 102, I mean as close to 100 as I can get. And then I can change the speed, you might be able to hear it. Like right now it's 60% duty cycle. %. 40% range. Doesn't sound like a very fast pump. Oh, shuts off at about probably 20%. Kick back on, maybe an 18% duty cycle. And then it climbs up to I'm gonna try going full blast. Maybe we'll go wide open. Oh, shuts off at 100. But anyway, this thing bench tests pretty neat. Ooh, stuck my finger in there. And that's the output. So you can bench test these if you have a device that will allow you to input a signal at 100 hertz, and then you can adjust the duty cycle to get the pump to spin. There you have it. So as promised, I'm going to show you a couple other valve bodies and how they've changed their design a little bit over the years. We started with the Ford, the early Ford. That's what we spent most of our time talking about. This is a later model Ford. This is a 2022. You're going to see very few changes. Matter of fact, it's pretty much the same. One of the things that is different, they got rid of the thermostatic bypass. I think the majority of the 10 speeds use this, basically this aluminum plug for the bypass. They don't actually use that thermostatic element like this one did. Another thing is that the clutch gain valve is missing or gone, omitted. So what they have now is just a spring and a plug. So basically that spring just pushes against this end plug up against that retainer. I'm sure it's just there so that this doesn't fall out. So this bore is completely open. There's no valve in this bore anymore. This bore right here is that houses the clutch gain valve in the 2017 unit that I went through. It doesn't exist in this 2022 unit. So aside from that, the lower valve body doesn't really seem to be any different. We still have the two solenoids, the line pressure and the torque converter clutch solenoid. Still have the anti-backflow valve and the TCC priority valve. We also have 4 of these valves that have 4 spools on them, basically, and then 2 of them that have 5. I don't think I pointed out in the 2017 model, but you can kind of see that this thing here has a little step in between these 2 spools. And you'd think this one would, but it doesn't. That one there, in a similar fashion, also has that step, kind of facing the opposite direction. And along those same lines, we see these valves right here, they have a step on this kind of the outer end right there. So similar to the 2017 valve body that we took apart, this section that we would normally associate with the manual valve, it, just like the 2017 unit, this one didn't have anything in there. Now what this typically would have, or I should say it could have, is a hydraulic park actuator system. That little shiny spot right there would house a solenoid that would pin the actual parking pawl into the released position when you're out of park. Electronically, they hold it, as well as hydraulically, they hold it out of park. So another thing I've kind of neglected, I think, to mention earlier on, is there's a number etched in or laser printed into the top of this solenoid body. When you look at that number right there, 222-56964-8968, that number right there is a solenoid strategy. They etched that in right into this valve body assembly, the one that houses all the solenoids. And that number should match up to the information that you have in the scan tool and also the sticker that's on the outside of the transmission. If you're putting a new valve body into a transmission, you need to update, using a scan tool, update the TCM with that number. That trains the TCM into knowing what the solenoid strategy is, so that way it has a head start at adapting and learning how this new valve body is going to operate in the transmission. So aside from a few minor changes, like putting a slug for the cooler bypass and also omitting that clutch gain control and just putting a plug in that bore, there's very little differences on the late model versus the early model Ford valve bodies. So now sitting in front of me is a valve body out of a General Motors 10L80, and you're going to see quite a few differences between the Ford and the GM valve body. Now this is their second generation. The first generation valve body was really not that much different from the way Ford did things, but the second generation is quite a bit different. One thing we could see initially is that, yeah, we do have these 6 solenoids just like we did on the Ford, but they're actually going to be in a different order than what Ford had it. So in this case here, we've got our torque converter clutch dampener, our isolator. We have these 3 others that start, stop, and then these 2 in addition. One thing that we have here on this is we actually have a manual valve. So that's something that our Ford units didn't have. Also, take a look here, we've got 4 plastic check balls. So if you're taking this apart, expecting no check balls to fall out, and then they roll it onto the bench. That's something that you have to be aware of. They've got check balls, not just on this side, but the other side of the valve body does too. When we look at the upper valve body, some of the same scenarios hold true. We've got check balls here. We've got 5, 1, 2, 3, 4, 5 check balls. Looking at this solenoid body, the lower valve body side, you can see the solenoids aren't really any different. The valves that they operate, they are a little bit different. Mainly the fact that all of them have 4 lands as opposed to some having 5 lands, some having 4. And you might notice when you take them apart that some of these valves have kind of like raised sections on the sides of the spools. I'm sure they're there to identify their differences more so than any functionality. Like for example, on this valve, these 3 lands are the same size, but this land is a little smaller. This is actually 572 thousandths. While the next one over, these spools are the same size. Matter of fact, these first 3 all have the same size spool. It's just the end one that's different. And on this case, where it's a little thicker there towards the edge, that's 552 thousandths. And that's going to be the same as the one next to it. And that's the reason why these 2 are identical. These ends right here are 552 thousandths of an inch in diameter. This one is 572 thousandths, just like the first one down here. And you can see it's got the same design. Now these 2 are a little different shade of anodizing, and it's the second spool over that actually has the thicker spot. And these are 564 thousandths on the end. So 564 for these 2, and these are 572, and these are 552. So those little thick sections hanging off those spools really don't serve any other purpose other than to identify their size, probably for quick assembly in the manufacturing plant. Now, obviously you'd want to keep these things in the same spot as you take them out, so it's a good idea to stay organized. One of the other things that's different is on this torque converter clutch priority valve, they don't have that little throwing star. Matter of fact, now they've got a little roll pin that goes through the valve body and pins this end plug in place. And another thing that they've done is they identified on the casting which solenoid or which clutch the different solenoids operate. D, A, B, E, F, C. Now moving over to the upper valve body side, a few valves are similar. We've got the lube control valves, we've got the cooler bypass valve right there, and we got a torque converter clutch regulator valve and a main line pressure valve. The valves that are different are going to be the feed limit high, feed limit low. Those are additions that General Motors has. And a couple other additions is we have this default select and this default disable valve. So those are things that we didn't have in the Ford. We didn't have these 2 default valves. We didn't have these feed limit valves. And to go along with that, we have this default disable solenoid. So this solenoid is going to work with these valves. Similar to the Ford unit, these solenoids also have band numbers on them. On the bottom, I see a 2 and a 3 on this one. I think that's a 2 and a 2 on this one. So hard to read. A 1 and a 3 on this one. 2 and a 2. I think a 1 and a 3 on that one. Even the line pressure solenoid has a band number. So that about sums up the difference between the second generation GM valve body and how it's different from the Ford. I'm going to show you one more General Motors variation. It's another second generation valve body, but they added yet another component to this auxiliary valve body, a actual sensor, and then it has a hydraulically actuated park system. So what I have in front of me right here is another second generation General Motors valve body. Now this is a little bit different than the previous one. This one, instead of having a manual valve, it has a park actuator. So this has got a hydraulically actuated park mechanism. So it pulls you in and out of park through hydraulics and through spring force. On this auxiliary valve body, we still have our default disable valve, but now we've got this range control valve. When this thing cycles over, there's a magnet on the end of this and it goes through this little sensor body. And it's a simple 2-wire sensor. It's actually a magnetoresistive or a Hall effect type sensor. So when this thing cycles over and that magnet finds its way into the actual sensor, it will change the current flow that's on these wires, and the computer can register that, and it'll know for sure that this valve stroked. So that is the magnet right there on the very end. It also has a similar valve or sensor so that it can check to make sure that this park rod actually moved. This actually has two switches. They're Hall effect type switches, so is this one. And these two switches will close to indicate the position of this park rod. There's a lot of spring force on this, and when we pull this valve all the way over, you can see that little spot where the solenoid can pin that manual valve in. This park lock solenoid, when energized, will lock that pencil tip out. You can see I can push it in easy. It's always stroked out, but since it's rounded, it won't be able to hold that park actuator in place. But when you energize it, it stays stiff, and then when that park actuator is slid all the way over, that pin that goes in there will lock that and keep it from falling back into park. So this thing's hydraulically moved out of park, and then it's mechanically held through this solenoid out of park. So that way, hopefully it won't accidentally fall back into park while you're driving down the road. That would be horrible. Aside from that, this valve body is not really that much different. So I go in deeper in the electrical operation of this transmission in the electronics video related to this transmission. In that video, I talk a little bit about the solenoids and how they're electronically controlled, more specifically through the TCM, do some like the frequency and the duty cycles and how they're actually electronically controlled. We talk about these sensors and how they operate, and I'll actually power these things up and show you what the computer would be seeing. Also go into the transmission case here, and we look at these speed sensors. These speed sensors are unique in the fact that they can actually measure not only RPM or speed, but they can measure direction. So we take a look at that, actually power these things up and show you on a scope what that looks like. So keep your eye open for the electronics video related to this unit if you want more detail on that. But aside from that, we're pretty much done. We've covered the guts and the pieces of the valve body. We've already gone through this transmission and the whole unit there. So at this point, we go through and reassemble all these parts, put them back in, and our transmission should be ready to go.